Okay, so this Module 9 skills test, it's entitled Wavelength Lab or Basic Wave Terminology. It's going to get you familiar with some basic wave terminology such as wavelength, frequency, and wave speed. Those are the three most important things you're going to hopefully understand by the time you're all done. So you hit begin, and you're going to initially see some settings. The options to change frequency, change speed, or to just start. And for this activity, you're just going to start. Now, eventually we are going to make some changes, but initially we're just going to go ahead and start the simulation. And what's going to happen is your simulator is going to immediately start making some waves. And you want to stop your simulator when it has created waves where the first wave created gets out to be 300 meters from the center. So I'm going to show you what that means. So notice that at the scale, the distance between each of these gray, the dark gray blocks is 100 meters. So therefore, here's my center. There's 100 meters, 200 meters, 300 meters, and sure enough, the first wave that I created has gotten that far. Okay. Now your values will be different. So this is just for illustration purposes. But once you've gotten this, once you've gotten yours to look like mine, again, it doesn't have to be the same number of rings. Your simulator is going to randomly generate waves, so yours might have different properties. But once your outer wave gets to that 300 meter mark, go ahead and pause it, take a screen grab, make sure your instructor sees not only that you've got your circles correct, but also that you have the time up there. So it took 3,420 milliseconds for my wave to get out to this distance. Again, yours is going to be different values because your waves are different. But that information is very important for question 2, because here you're going to be calculating the speed of your wave in meters per second. So since your wave has traveled, your outer wave has traveled 300 meters in a certain amount of time, you can calculate its speed. Now, one thing I do caution you, make sure that you convert your speed. I want your answers in meters per second, not meters per millisecond. So make sure you convert this to seconds. The way you do that is you could just move your decimal place 3 places to the left. So notice that I've got an imaginary decimal place. I can move 1, 2, 3. So 3,420 milliseconds is equivalent to 3.42 seconds. And that's what you need to use to do your calculation. Okay, now, before you get to question 3, it tells you to hit end. That's going to take you back to the settings screen. And we're not going to change the wave speed. We just calculated the wave speed, so we don't want to mess with that. However, we are going to change the frequency. So when you click on change frequency, you're actually asked to click this little button in the middle 3 times, and you've got to do it at a pretty constant basis. So you need to click it 3 times quick, 3 times slow, but make sure that the time in between clicks is essentially constant. Otherwise, the simulation is going to ask you to do it again. So I can click it 1, 2, 3 times, and it looks like my new frequency is established. Now it's going to start creating waves using my new frequency. And you're going to do that, let it go for 10,000 milliseconds. So again, yours is going to be different than mine, but I would just let mine go, let mine go, let mine go, until I want this counter to get up to 10,000 milliseconds. And then I'll pause it. And again, it doesn't have to be perfect, close enough, okay? Close enough. What you do then is you start from your outermost circle and start counting in the number of waves, okay? And again, this is all in the instructions. You also need to figure out the frequency of your wave. I'm sorry, you can figure out the frequency of the wave by knowing that it has a certain number of cycles has been created in this amount of time. Remember, frequency is cycles per second, so you should be able to find out the frequency, calculate the frequency of your wave. You should also be able to determine the wavelength of your wave by just measuring the distance between wave crests. And again, use these blocks. So in between each of the dark gray lines is 100 meters. So therefore, each of the individual little boxes, there's 10 of them. So each of those is 10 meters. And you're not limited to counting in full little blocks. You can actually use fractions of little blocks. Again, the more accurate you can be with your wavelength, the better your calculations are going to be. But once you've done that, you're going to actually create a table because you're going to keep your wave speed the same, but you're going to be changing the frequency. So once you've done it this time, now go back in, hit end again, and change your frequency. Don't change the speed though, just change the frequency. Click it 3 times with a different pacing. And you're going to do the same thing. Let it go for 10,000 milliseconds, figure out the frequency, figure out the wavelength, collect your data, and then you're going to graph it. So you're going to go into a graphing program, and you're going to graph your wavelength on the y-axis and your frequency on the x-axis. You're going to put your frequency values on the x-axis. You're going to put your wavelength on your y-axis. And then the question is, what kind of fit does your graph look like? So you'll graph it, you'll fit it, and you'll see which one is most appropriate for your data. And then you draw a conclusion to question 4. Now, question 5 asks you to refer back to your wave speed. So you've already learned, or you've already figured out a bunch of frequencies and a bunch of wavelengths for a wave that had a certain speed. So now you're asked to figure out what's the mathematical relationship between frequency, wavelength, and wave speed. That takes care of question 5. Before you go into question 6, you can go ahead and you'll wind up hitting end, coming back to this settings page. Now, we're not going to change the frequency. We're going to change the speed of the wave. So you can go ahead and click on speed this time. Change the speed. And again, you're going to see this little slider. You can choose to make a fast wave or a slow wave, whatever the case may be. I chose a relatively fast wave. And so here, the important thing is I'm going to let the thing start, and I've got to stop it, again, when it reaches that 300 meter mark. And so I should be able to figure out the wave speed. Again, we already calculated wave speed once before. Remember, our wave traveled this distance, 300 meters, in this amount of time. So I can calculate the wave speed. I can also figure out the wavelength, again, measuring this distance from crest to crest. You're going to do this a bunch of times. Once you've gotten that data, go back to end, choose a different speed. Leave your frequency the same, but now choose a different speed and let it do it. Again, go out to 300 meters, measure your wave speed, your wavelength, and again, now you're going to plot this stuff again. So when you're plotting it, in this case, you're going to be plotting wavelength on the y-axis and speed on the x-axis. So wavelength still on the y-axis. Now I'm just going to put speed values on the x-axis. Again, graph it, fit it, see which kind of fit best fits your data. And then finally, there's a little wrap-up question for number 7. So anyway, good luck and have fun.